All right, what is up? It's your boy, the Knologist. Another day, another Leetcode. This is a medium, and it's called remove nth node from end of list. From end of list. Okay, so given the head of a linked list, okay, cool. So what they usually give you, because that's the only address that matters. Remove the nth node from the end of the list and return its head. So if n equals 2, 0, 1, 2. So if n equals 2, remove from the end of the list. Okay, so nth node from the end of the list. So 1, 2. Get rid of the 4. Okay. So the size of the linked list could be from 1 to 30. Okay, cool. Node values don't really matter because we're looking at positions. Could you do this in one pass? Oh, we'll figure that part after. But for now, all I want to do is just solve. Because in most cases, you guys will be in positions where it'll be timed and you don't have time to think, right? So, as usual, let's create something called stores to store the values of your linked list. Okay. Then I want to go while none. So let's just call this positions. And then let's say it's for number 4, right? So the first node for 0, so n equals 1. I guess that's a base case, but basically whatever the position is, I want to get that value at that position so I can just add all the nodes to the positions list, and if I get to that specific node, I skip it. So while head equals none. Positions dot append head, so the full node, head equals head dot next So that, I don't actually care about the value. The reason why I don't use the value is because you could have nodes with the same value, right? Like you have 1, 1, 1, 1, 1. So like, how would you know based on the value whether you're at the first node, the second node, or which one to remove? Right? You might remove the wrong one or something. I don't know. So I'm gonna actually use the node itself that way, because that's a unique object. And if it's equal to that object, then I could skip it. Pop in Python. Try it yourself. Okay, so all I want to do is pop -1. Does that work? Apple, banana. Perfect. So I just pop whatever n is. So the value of n is, so pop positions.pop -n. So now I can store the pop value into here. Pop -n equals or let's put removed. So that's one pass. So that's the exact one I want to pop. So I store all the nodes into here. I figure out the exact node I want to pop, and I store it in this removed value, and I just run it again while. Well, return the head node. So I'm just going to adjust the list. Head is a position in memory. So temp equals and then if temp.next equals removed. So if it's this node, So this is what I'm going to show you. So temp.next.next. So basically, let's go to the whiteboard. This is how a linked list works. This is the head. And the head contains access to this whole list. But you only get to see the first node here, this node. You only get to see the head node. So all you need is a head node, and then you go one by one to the other items. You don't get to see all the other items off the bat. You only get the head node. So based off this, you have to pass through everything. So let's say 1, 2, 3, 4 values as stored in my array. 1, 2, 3, 4. And let's say this is the target node. If let's say I go back to my code here. Now I want to find the positions pop.negative_n. Let's say it's -3 removed. So I'm going to say removed is equal to 3. So now it's going to go, when I go through this while loop, if node equals 3, so I go 1, node next, 2, if node.next is equal to removed, so 3, instead of going here, I go directly here. I don't go here. So node.next.next. So that way I get my new head. The new head node leads to 1, 2, and then we get rid of this, 4. And then null. That's what happens when you do this. That's what I'm trying to achieve here. That's why I just return the head node at the very end. That way it just links at the beginning and you can trace it back. And that should work. Removed equals positions. Let's try it now. Time limit exceeded. Oh, because I have to make this if temp equals temp.next. Because I have to keep it moving. Only when I find that it's equal to that remove value, then I make it next.next. Otherwise, I just keep going next, 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 next.next, next, next. You know what I'm saying? So let's try this now. This should work. Wrong answer. Okay, let's see. N equals 2, 4, 5, 1, 2, 3, 4, 5. I'll put 1, 2, 3, 4, 5. Given the header, remove the nth node from the end of the list, return its head. Removed equals positions.popN. Head is the full node. Oh, temp.append head. That's why. It should be temp. There, that should work. It's the right logic. So I need to figure out why it's not removing. Temp.append, temp.next. Positions. Okay, what's the time? 14 minutes. Okay, so positions. Temp equals temp.next. Remove positions pop n. Temp equals head. Let's put while temp.next. Okay. Does it pass any of the tests? Okay, n has to be less than or equal to the size. It's between 1 and or less than or equal to the size. Let's try that. I'm just curious to see. Let me exit this. So if head.next, let's put this, if head.next equals 1 and n equals 1, return 1, run positions.pop negative n. There we go. So you pass the second test case here. You get none as the output. Okay, so now it's this 4, 5. For some reason, it's not removing this value. Positions dot pop negative n from the end. So 4, let's say it was 2. There should be 1, 2 from the end. Should be 1, 2 from the end. It should pop. While temp.next is not equal to none. positions dot append temp. Temp equals temp dot next. Removed equals positions. So add every value. So temp equals head. Append temp. Temp equals temp dot next. Positions dot append temp. Temp until it gets to the very end. Until it gets to 4. Until it gets to 5, right? And then 5 dot next is null. Doesn't do it. Remove positions dot pop. Okay, let's try array dot remove. Okay, so pop is for index, thing is for none. What if I go remove? What's the time? What's the time? What's the time? Okay, I'm at 23 minutes. Fridge. Return head. Return its head. Okay, so return head. Nth node from the end of the list. Temp.next, next. So it's temp equals temp.next. Okay, so if I want to skip it, Oh, this is an assignment operator. If temp.next equals remove temp equals temp.next.next. Otherwise, temp equals temp.next. Let's try that. Let's do this. We're almost there. I don't know why. Maybe I'm messing up some sort of pointer. So temp.next equals the removed, because right now I'm always on the current one. So right now I'm on the head node. So let's say I go temp. If temp.next is equal to 4, then I go temp equals temp.next.next. Boom, 5. And then no. Because then I don't want to override it. So I don't want to override it by going temp equals temp.next. So I have to hit continue. What if I just go new temp? Maybe it's because I'm using the same variable. Well, that shouldn't be the issue. What if I return new temp? Does that fix it? Expected 1, 2, 3, 5. Head. Temp equals head. Because I don't want to lose my position. All the way to null. Add it. Okay, where am I at? Okay, I'm at 30 minutes. So let's take it to ChatGPT. Where did I lose? my way. Instructions. I bet you it's something small. It always is, right? Like, that's why. At 30 minutes, I'm just gonna quickly go to the end. Fix my solution. Fix my solution using my code. How you handled the removal of the node. Main issue was how you're trying to update the next pointer of the node. This is correct. Okay, so head equals, okay, if head equals 1, that's already there. Positions temp head. Okay, cool. That's already there. All temp is not none. Positions out of pen temp. Temp equals temp dot next. Okay. Removed equals positions negative n. Positions. Okay, so that's basically the same thing. Let's try that. I just want to see. Is it because I use pop? Okay, so positions negative n. Okay, so that's still the same. If removed equals head, if removed equals head, return head dot next. Code is not indented properly. Just fix this. This is not right because the indentation is not there. You see how it's all you see it's still wrong. fix should look exactly like this without okay, so if the removed node is the head, that's head.next. So then we wouldn't need this. So this in positions we can keep. We can remove this. And then if return head.next. Which is the exact same thing as the above conditional. If that's the one to be removed, return none. New temp is head. New temp.next. Okay, so it kept the exact. New temp.next equals new temp.next.next. Oh, then you can just break it right there. You don't have to continue it. Otherwise, just keep going to the next node. Okay, so that makes sense. Okay, so this is where the flaw is. There we go. This is where that line is. This, all I wanted to show you is that it's just that line. New temp.next. I was going new temp equals new temp.next.next. It was new temp.next, the next value. So if this value is to be removed, then I want to update this value, right? I was updating this value before, new temp. I was looking for new temp.next to be updated, right? So that means inside this condition, if this new temp.next equals removed, then new temp.next needs to skip that value. That's the real value. That's the real solution that I was looking for. So if I submit it, this should be, see, it keeps the exact same logic because I knew everything I did was correct. It's like there's just one tiny thing, and it was this dot next. I just had to add dot next to this. So it beats 99.85% of other solutions, 77.95% of memory, but between other solutions, it beats that. So it beats 99.85 in runtime, and beats 77.95 in memory. So if you like this question, please give it a thumbs up, subscribe, comment below. Knologist out.